Hello there, I'm Thomas Hatsios. I'm an American pilot flying the Boeing 787-900 night flight. We're going to be overflying Zurich, Switzerland, Germany. Then coming back to the Zurich International Airport on runway 1449. Let's localize the landing in the cockpit. For the pre-takeoff preparation of the quality wings, Boeing 787-900 Microsoft Flight Simulator X, I'm going to start showing the cockpit instruments, the displays, and the functions of the Boeing 787-900 jet aircraft. I'm gonna start with the primary flight display. The displays are the airspeed indicated, the airspeed selected from the autopilot flight director system panel, the ground speed, the radio altitude above the ground level, the barometric pressure above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb of the aircraft in 10,000 feet per minute, or the steepness of the trigonometric angles in degrees can climb descent. We have also the artificial horizon with the attitude indicator, the pixelary degrees and the bank angle in degrees. We have the Lszh localizer, the instrument landing system of the airport runways we use for takeoff and for landing. We have the threshold antennas that transmit the radio frequency that is received from the on-board antennas of the aircraft and is displayed in the primary flight display, like the horizontal localizer and the vertical glide slope, that is the angle of approach. So we have to tune a unique radio frequency each time we take off or land in a different runway and align with the magnetic north pole heading in the autopilot setting for the headings guidance. So we have also the Lszh localizer crossbus. We have the flight director crossbus for manual guidance of the aircraft and the autopilot crossbus for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies and the flight mode on 0 with the autopilot and the autothrottle. Later on vertical navigation mode, we have also the side that displays the magnetic heading and track. Also the decorative display of the flight plan. We can see also the flight plan we have created in the navigation display in the horizontal and vertical profile. Over here you can see the horizontal and vertical profile of the navigation display. You can see also the side. Later we're gonna use the flight management computer over here. I'm gonna create a flight plan or a flight path or a route. You're gonna see I'm gonna set up the flight plan for this flight. It's gonna be set a waypoint by a waypoint, one by another. So you will see the purple or magenta line of the waypoints and the purple line also in the climb and the horizontal profile of the aircraft as we fly. So you can see the flight management computer. You can see also the mouse pad, the keyboard. We have the screen display, the mouse you're gonna see later, and the mouse pad to set up the flight management computer. I'm gonna show you the navigation display. So the navigation display displays the GPS position of the aircraft, the magnetic north pole and the geographic north pole and magnetic variation depending on where we are in the world. We have also the terrain and weather reflections from the weather radar. You can see the red, green and yellow or rubber color of the terrain around you. Also depending on the distance the aircraft is away from the terrain in front of us or below, you can see mostly green and yellow below you. So we have also as we find the vertical display profile, we can have also the sea, lakes and the rivers with blue. We have also the terrain map with the airports. You can see the airport's four-letter account name. Its airport is displayed, the distance from the aircraft where we are located. Also our own airport we're gonna use for takeoff and for landing. You can see the runways we're gonna use for takeoff and for landing and the taxiways, the runway length and the runway heading and other information. Also we have the navigation aids, the nav aids, which are the workstations, ADFs and DBs. Also the waypoints, which are horizontal and vertical navigation fixes and alternate speed constraints. We're gonna be having to fly with some waypoints in this flight. As we're gonna select here from the flight plan, some computer I tell you, we're gonna have the flight plan later displayed with a purple or magenta line. And this is gonna be the flight plan, the autopilot and flight director system panel is gonna follow. We connect the LNAV and the VNAV, the lateral navigation, the vertical navigation of the aircraft that takes the information of the flight plan from the flight management computer. So we can also fly that flight plan line manually if we need. We have also on the navigation display, you can see other aircraft that fly around aircraft are displayed using the transponder. The display in ADC transmitter receiver transmits our frequency to other aircraft and the air traffic control and receives from other aircraft. You can calculate the radio frequency changes, the other aircraft position and distance and bearing from our aircraft. You can calculate the distance up to 40 nautical miles or 72 kilometers in a 360 degrees radial around the aircraft. You can calculate the other aircraft altitude difference from our aircraft, how many hundreds and thousands feet are above or below our aircraft. It will display the other aircraft with a diamond shape with the altitude displayed next to the aircraft. Also, whether the other aircraft are climbing or descending, it will show us an arrow up or arrow down. It will show us also the other aircraft closing in velocity. We can calculate that, so it will give us a warning if we have an incoming collision in the air with another aircraft. It will give us a warning from the TICA system, the traffic collision and advisory system of the aircraft, so we'll have to make an avoidance maneuver in the air. Also in the ground, you can display the other aircraft in the runways and the taxiways, so we have awareness about the other aircraft, about the traffic in the other of the other aircraft in the runways and the taxiways. As you can see here, the runways and the taxiways of the airport. So we have here also, I'm gonna show you the flight controls of the aircraft of the Boeing 787. What I have here, the side stick, the Lszh Extreme 3D, so we can climb and we can descend. Use the side stick up and down or yoke of the Boeing 787. I have the side stick of the Airbus to make the controls. Also make turns to the left, to make turns to the right. Use the control wheel to control the ailerons and the spoilers to make left and right turns. You can see how fast and responsive it is. Also the rudder pedals. We can control the vertical rudder and the nose wheel steering in the ground using the rudder pedals. Also the nose wheel steering you can control using the tiller function here. So I hope you like the cockpit. You will see all the aircraft systems before we go into full manual flight in the end part of the video, so stay with me until the end part of the video. You see the complete flight from takeoff, climb, cruises and approach and landing. After we're gonna make an NZXR demonstration to complete all flight systems and the flight plans, my computer and the autopilot with the flight plan. So you can see I have the mouse pad here and the keyboard, the computer, also the side stick. So this is how you use the quality wings Boeing 787 aircraft. You can see I can climb and descend the aircraft when we go into flight later. Also the overhead panel, all systems, the thrust levers here. You can activate the thrust commanded by the NZIGs. You will see the percentages of the thrust commanded here. I will talk to you about later. You can see if we apply full takeoff thrust, we will have the warning. I will not configure it for takeoff like this. So we use idle thrust again. So you can see this is the N1, which is low speed solid shaft, low pressure compression to one of the turbo fan, engine, exhaust gas temperature planes, and then 2, which is high speed solid shaft, high pressure compression to one of the turbo fan, which is engine, fuel flow, planes per hour, 1000 kilograms, 1000 grams, oil pressure, oil temperature, oil quantity, and the vibration of the N2 stage of the engine. Also you can see the stabilizer trim. I will talk to you now about the flight controls, the flaps, also part of the flight controls, and the rudder trim. The landing gear extend or retract, alternate gear over here, lock override, the retract speed for the landing gear and the extend speed, the auto brakes over here. You can set reject the takeoff, RTO, or for landing 1, 2, 3, 4. We cannot send it like now because we're not in landing phase yet. So we have cabin altitude here, the pressurization of the aircraft panel, the cabin pressurization. As you can see, the altitude right now is 1,400 feet. The rate of cabin pressurization when we climb or we descend. The pressurization, climb or descend pressurization, differential pressure, landing altitude, and the outflow valves position that control the pressurization of the aircraft, gross weight, total fuel on board, and the fuel temperature. And now some more information. Also, you can see the green limit here, 99.1%, and TO with green is the takeoff limit for the total air temperature, 99.1%. Using the takeoff thrust over here. So you'll see later how we're gonna use these systems. Um, so we have here so here you can see other systems that we have, also the outside view. So you can see here we have the primary flight display that displays the airspeed indicated, the airspeed selected from the autopilot flight director system panel. With purple, the altitude selected from the autopilot flight director system panel, the barometric altitude, the vertical rate of climb descent of the aircraft. This is the vertical speed indicator, 500, 1000, 1500, 2000, 3000, 6000 feet. This is needle moving up when we climb, moving down when we descend. You can see the pitch ladder in degrees and the bank angle in degrees. They're all the aircraft flight director, radio altitude above the ground level, takeoff, ground set. The outside magnetic heading and track over here. So we have 2.5, 5, 7.5, 10, 12.5, 15, 17.5, 20 degrees for pitch up and pitch down. Also the bank roll is like 5, 10, 20, 30, 45, 60 degrees, 67 degrees in bank roll, left and right turns. So the airspeed right now is 200 knots and the altitude 10,000 feet. Also the heading 360. You can see also here we have the landing altitude and the barometric pressure, 29.92 inches of mercury or 1013 hectopascals. You can see no V speeds now on the landing altitude. So we set here from the FS panel, as you can see, the barometric altitude, inches of mercury or hectopascals. We can switch either one and increase or decrease the barometric pressure. As you can see, baro set standard. So we have 1013 hectopascals, so 39.92 inches of mercury. Increase or decrease this value would change the altitude displayed, minimum radio baro. Also we have some switches here for the displays. Accept, cancel, reject, some warnings here. So the displays you can change the range, the plan, the map view over here. This is for this section of the map and the navigation display. So the barometric pressure, you can see now we have this barometric pressure here, 29.92 inches of mercury, give us this barometric altitude 1430 from the pitot. Static tubes and the pitot dynamics, we have the airspeed, also the vertical rate of climb and descent, the flight directors. So all these air data are controlled from the air data computer over here. Pitot static, pitot dynamic, GPS receivers, magnetic North Pole, geographic North Pole. So we have also over here you can see the terrain map, the navigation display. You can see the terrain elevation with red 4,500 feet, with green with yellow or other 1,600 feet. The distance, the other airport here you can see, for instance, the DTL is the Düsseldorf airport. It's in front of us. LFSD, another one, LFSB. So here is Germany, here is Switzerland, here is France. If you look further away with the map, you will see more airports. You can see Germany here in France on this side, and Switzerland over here with the Swiss Alps. You can see also the vertical. You pull it closer and closer in the map. You can see in the vertical display we have the terrain in front of us. You can see the aircraft symbol where you're gonna be flying. You're gonna be above the terrain, like 5,000 feet. You will see the terrain below you with a yellow and green color in the distance. Like now it's 10 nautical, 10 nautical miles away. 2.5 nautical miles, 7.5. And also the altitude set from the autopilot again. You can see more information. Then you're gonna set the flight running. You'll see more information, a lot more interesting things. So we have here also so you will see now we have the flight controls. I'm gonna show you the flight controls, how to control the flight controls for the Boeing 787 with the side stick. You can see also we have the horizontal trim stabilizer over here. In the side stick I have the autopilot disengage for the Airbus, and the side stick priority, the push to talk button. So for the Boeing we have here the horizontal trim, the horizontal tail trim stabilizer, the normal and the alternate trim switch and the cutoff switch. Also the primary flight control computers over here, the normal and the alternate mode and the direct mode if we have a failure. Normal, alternate, direct mode if we have failure we disconnect. Over here the stabilizer trim switch from normal to cutoff if you have failure of the hydraulic systems. You can see here this switch is from normal to cutoff for the stabilizer trim. This is for all Boeing aircraft. So as you can see we have a failure of the hydraulic systems, pumps, engine driving or electric driving, which are also air pressurized, that will affect, it will degrade the primary flight control computers from normal to alternate or direct mode. We're gonna have a failure of the auto trim functions, and this is a fly-by-wire aircraft. It has the flight control computers. It can also trim itself in flight, trim automatically, the auto trim. We have also the manual trim. We can apply the manual trim with the switches, as I'm gonna show you now. So we have failure of the hydraulics that control the elevator movement of the stabilizer movement, so we cannot have the auto trim function. Probably we have to disconnect the switches here. So you can see here we have the tail. You can see the side stick, climb and descend, the elevator movements. So we have the elevator trim for the Boeing 787. We have also the stabilizer trim, some aircraft, the rudder trim, also the rudder pedals, ailerons and spoilers. Gonna see all flight controls now. So I'm gonna start showing you what we do with these switches here. You can see the horizontal trim stabilizer over here. We have the elevator, a better view of the tag here. So you can see elevator trim, left click down, right click up, left click down, right click up over here. So this way you trim up the elevator. If you push the switch this way and you pitch the nose of the aircraft up, you have this aerodynamic effect. And also if you push the switch down, you have the nose pitch down aerodynamic effect in flight. So you balance the aircraft when you fly with this switch over here. Applying the elevator trim like this, elevator trim, this way trim elevator up, pitch the nose up, and this way trim elevator down, pitch the nose down. We had an aircraft here coming for landing, so you can see the elevator trim, the tags here for the elevator trim again. So you see elevator trim, left click down, right click up, so right click, this way you trim the elevator up, this way you trim the elevator down. Also we have the autopilot disengage switch and the head-up declutter switch. We have the flap speeds over here, the limits. Also you can see how many degrees you pitch the elevator You trim the elevator axle, stabilizer trim. Over here you can see 4.25 is inside that green band is set for takeoff. Also the rudder trim and the flaps position. So I don't use the rudder trim too much, I don't need it. I use mostly the elevator trim. You have the alternate trim over here. This trim switch is similar, maybe more to the Embraer aircraft, these trim switches or the CRJ. So we have the elevator trim, left click down, right click up. You can see nose up and nose down again. So this is the alternate trim switch over here. You can see nose up and nose down. This is elevator up and elevator down. So it's very easy to use. Also we have the parking brakes here set, and this is the cutoff switch for the left and the right horizontal stabilizer. It will disconnect the auto trim function. So if you have failure, as I tell you already, from the hydraulic system, that will affect the flight control computers from normal to alternator direct mode. You're gonna lose the autopilot and the auto trim. So you need to come down here. This is for all Boeing aircraft: Boeing 737, Boeing 757, Boeing 767, Boeing 777, Boeing 787. You open this red guarded switch from normal to alternate to cutoff switch, either one or both, and you use only the alternate switch trim or the manual over here. So you lose the automatic trim, you lose the autopilot like this. These are the grade of the flight control computers. So you use only manual trim and also manual flight controls. So I'm gonna show you a couple more things. So this is fly-by-wire aircraft. It has its flight control computers like the Airbus aircraft. When we fly, it has normally the alternate and the direct mode of flight control computers. It has also the Airbus has the backup mechanical mode. So when we fly in the normal mode, all flight controls are limited in terms of G acceleration, where G is the acceleration of the Earth's gravity. So when we climb, descend, or make turns or stay level flight, we have the acceleration calculations. So in the Airbus, you move the side stick up, you climb 30 degrees up or 1.5 G. Also you can descend, you push the side stick down minus 15 degrees or minus half G. Also you can make turns left 67 degrees, right 67 degrees or 2.8 G in full side stick deflection, or if you leave the side stick neutral, you go back to 33 degrees, then you need to move the side stick again to stay level. Also you have the 1G stall. You can see the stall in the Airbus displayed in the primary flight display, also in the Boeing. So you have the alpha protection on this stall for the Airbus aircraft, also the maximum speed protection, low speed protection, other protections from the flight control computers. So the Boeing aircraft now, the Boeing 777 and Boeing 787 also have flight control computers, are fly-by-wire aircraft. So when you fly, you move the flight controls. You're gonna see now, I'm gonna show you the flight controls. So I will explain you now some things we need to know about flying the aircraft for the air transport pilot license and the commercial pilot license. For the ATPL theory and CPL theory, we need to know aerodynamics, also aeronautical and aerospace engineering, flight dynamics, the Newton's physics, and the Bernoulli theory of fluids. So also the outside view, and I will explain you the systems of the aircraft we need to know for flying the aircraft, also the flight control system. So you can see here we have the outside view. You can see the surface area of the wings hold the weight of the aircraft when the aircraft is airborne. So we divide the weight of the aircraft over the surface area of the wings, and the aerodynamic lift produced from the airflow as we move the aircraft using the thrust from the engines. It accelerates, so the lift produced from the wings acts over the weight that acts down into the wings. So we have here also the thrust vectors from the jet engines that propulse, that move the aircraft there. So this is a jet airplane, as you can see, beautiful jet aircraft. So we have the jet engines, we have the high pressure compressor and turbine, and the high speed starter and shaft. Also the low pressure compressor and turbine, and the low speed starter and shaft in the front section. Also the fan for the bypasser of a jet engine. You can see the bypasser is surrounding, is the round from the core of the high pressure compressor turbine and the low pressure compressor turbine. So we have the exhaust gases from the jet blast over here from the exhaust cone, and we have high pressure below the wings, the airflow moving slower below the wings, which pressurize the aircraft weight and wings out into the air. We have higher airspeed above the wings, which sucks the aircraft's weight and wings up into the air to the aerodynamic lift. Also, you can see we have the fuel lines for the engines. We have the fuel lines inside here from the fuel booster pumps and the low and high pressure fuel valves. We have also the wing and engine on the ice over here. Hot air from the engines coming in from the manifold. So we have the left and the right wing fuel tank, the center tank over here. Also we have them in aerodynamic order where the maximum aerodynamic lift occurs in the forward wings. It's also the position where the center of pressure is moving back and forth in the top surface of the wings. Also the airflow becomes detached from the top surface of the wings, and we have the wing stall in the air. So the stall wings, you will see the airspeed here indicated. In the primary flight display, we're gonna have an amber, yellow and red color indication just below the airspeed when flying. It's gonna show us the stall speed and the angle of stall. So if we reach the stall speed or the angle of stall, we need to apply in the air the side stick down, the Boeing the yoke down, and a full thrust levers, advance the thrust to increase the airspeed after decrease the stall angle. So this is stall avoidance. So the main aerodynamic chord position is where the yawing axis is, the center of gravity over here. So we can yaw the aircraft through the center of gravity using the rudder, left and right turns in the air. Also the nose wheel steering over here, the forward nose wheel steering in the ground is used simultaneously with the rudder control by moving the rudder pedals automatically from the computers. You don't need to do nothing for that. You have both rudder and nose wheel. Also you have the nose wheel to that in lower speed for high deflections like 76 degrees. So the rudder is aerodynamically effective above 45 knots or 72 kilometers an hour, and we take off with 250. So we have the forward nose wheel is active from 0 knots up to 45 knots, 76 degrees left and right turn movement. And we have the rudder above 45 knots is aerodynamically effective. So above 45 knots the computer will automatically, you don't have to do anything, decrease the deflection of the forward nose wheels from 76 to like 7.6 degrees to the left and right. So as we increase the airspeed for takeoff, we have more rudder deflection, so we have less input from the nose wheel. At 80 nautical miles per hour or 144 kilometers an hour, the computer will deactivate, will lock the forward nose wheel to 0 deflection, and we're going to be having only the rudder for controlling the aircraft until takeoff at 250 kilometers an hour or 140 knots. Also when we land, we have the inverse is happening. We have the same thing. We have the rudder first effective from touchdown all the way down to slow down. The nose wheel is coming in automatically from the computers. So this is the theory of the rudder control and the nose wheel together to control in the ground. In the air we have only the rudder to control the left and right turn mainly. So the rudder pedals, as you can see, and also I'm gonna show you The rudder pedals also have the toe brakes in the top surface of the rudder pedals. Also we have one more axis here from wingtip to wingtip. It's the pitch axis of the aircraft. We can pull the side stick back and climb the aircraft, or push the side stick forward and descend. So you pull the weight up, you climb, you pull the weight down, you descend. You have the elevator to do this job for you. As you can see, very easy, very fast. The response from the side stick. In the Boeing, as you can see inside, we have the yoke for climb. Descent is the same thing like the side stick, no difference at all. Same deflection is happening. Also when you fly, there is no difference in the flight control, the feeling. So you climb and you descend, you pull the weight up, you climb, you pull the weight down, you descend. So we have one more thing to see here. We have one more axis from nose to tail. This is the longitudinal axis. So in the Airbus you have the side stick left and right movement like this. You use the ailerons and the spoilers deflection. You can see the ailerons and spoilers over here. Spoilers and ailerons. When you move in the Airbus left and right, side stick in the Boeing is the. Also we have one more flight control. We have the flapper in the Boeing. So you can see now the spoilers extended for speed brakes over here, and the flaps also are fully extended, as you can see in the slots. So we have one more for controlling the ailerons and the spoilers. You can see aerodynamic lift difference between the left and the right wing when flying. It will make the aircraft roll in either in the left or the right direction. So in the Boeing you have the side stick controlling the control wheel. Same thing again, no difference with the Airbus control. The Boeing have the same identical flight controls. Rudder pedals are the same. You can use flight controls together, coordinated flight as they say in flying the aircraft, or use either, only one control surface at a time. No problem with that. Also the Boeing you have to use, you can see both captain and the first officer are interconnected and move together in flight. You need to use some force in the control column or the control wheel in the yoke of the Boeing 787 to take either side, override the other. In the Airbus you have the side stick priority button. Also both the Airbus and the Boeing have control. The rudder pedals are interconnected, no difference to that at all. So we can see here again, this is all for the flight controls right now. You can see one more view of the flight controls right now. I'm gonna show you. Then we're gonna make the rest of the systems of the aircraft. So I'm gonna show you again now the flight controls here. I control the side stick, the yoke. Also you can see we have an aircraft coming in for landing. So we spotted another aircraft over here, a Boeing 737-800. As you can see, it's coming for landing. Just started down in the runway, as you can see. So we have over here one more view of the flight controls of the Boeing 787. Then I'm gonna show you how to use the flight management computer, create a flight plan and make this demonstration. So here again you see the side stick that I have, as it's in 3D. Also this view for controlling the flight controls. As you can see, so we can climb and we can descend like this, very easy. As you can see, climb, descend, make turns to the right, make turns to the left. So I hope you like. Both you can see the side stick deflection is proportional to the yoke deflection over here. Hope you have the view of the screen now. So we climb, we descend, we make turns to the right, turns to the left like this. Use the side stick, push the talk button. We have the horizontal trim stabilizer that I talked to you. Trim the horizontal tail over here. Also the thrust control, the thrust levers. You can actuate the thrust over here, commanded by the engines, moving forward or aft. Also the thrust reverse. The auto throttle disengage. So hope you like the control that I have here. And the side stick, you can see moving the yoke of the side stick, no difference at all. Same flight control. Also make turns right and left over here. Also the outside view. So you can see the outside view. You climb, you descend, make turns using the rudder. Left and right rudder. Use the elevator for climb and descend. You can see how fast the side stick move. Also ailerons and spoilers like this. All flight controls together, coordinated flight. So this is the principle of the flight controls of the Boeing and the Airbus aircraft. Also the Embraer and CRJ aircraft have the same principles, no difference at all. So I'm gonna show you now the flight management computer. I will input the data. We need to create a flight plan. This flight plan is going to be followed by the autopilot flight director system panel. We need to flight connect the autopilot with the LNAV and the VNAV function, the lateral navigation, vertical navigation of the autopilot director system panel. Or we can fly manually. There is no problem to that either. So you see the mouse pad here and the keyboard that I have to input in the screens here. So I will use this mouse pad here for the flight management computer to control the inputs, also the keyboard, the screen, so we can change the modes now. We have identity, position, performance, takeoff, approach, and unseat status, flight plans. So we go in this view over here. So we can go here. So you see a nice view of the aircraft cockpit again. A better view of the screens here. So you can use identity. You can see the Boeing 787 model GNX engines. Install the air cycle, the position, Lszh airport. We can align the IRS inertial reference system with the GPS position, the longitude and the latitude, and also the magnetic north pole and geographic north pole. Laser gyroscope. So we have performance here. 0 fuel weight plus fuel on board, the gross weight for takeoff. Reserve fuel, cruising altitude, in flight cost index, minimum fuel temperature below which the fuel phase and the center of gravity. In flight we have the route Lszh airport here, Zurich International. Copy paste, departure and arrival, origin destination. Runway 14 you can use for takeoff, departure and arrival. Over here select runway 14, runway 10, runway 16, runway 28, runway 32, select runway 14. Transit to Alpha is the seats, the other instrument departure waypoints and fixes for the initial departure. Then we have the arrivals. We can use runway 16, 2834, boom, 16, ILS 14, ILS 16, ILS 28, ILS 34, GLS 14, localizer 28, localizer 34. So we'll use ILS 14, trans waypoint Amiki over here, and trans the stars and other terminal arrival waypoints and fixes, and horizontal vertical navigation fixes, and airspeed and altitude constraints. Also the ILS localizer for the approach and landing is gonna be set here. You can see arrival in the ILS localizer. As displayed, ILS localizer, Negra 1 Alpha, it says approaches with an ILS localizer over here, as you can see. so this is important for us to use for approach and landing. So we have also the legs here, the route, the first waypoint after departure, make turn in the air, left turn Zurich 6 nautical miles, then climb to the Nigria, make the right turn, descend Zurich 701, approach and landing. So we initialize first up. Zero fuel weight 322.7 thousand pounds, plus fuel on board 33,000, gross weight for takeoff 356.6. The reserve fuel 5%, the cruising altitude 25,300 feet, or almost cost index here 100%, fuel freezing temperature minus 37 degrees, and the cruising center of gravity is gonna be 28%. So the legs, we press the execute button here and we activate this route. Now it's gonna display with a purple and white. So we have the first waypoint after takeoff, 2 nautical miles, 250 knots and 1,100 feet. Zurich will make left turn after 1, 3, 5, 6 nautical miles, 300 knots, 6,000 above the sea level. Nigria 071 kd, 26 nautical miles from Zurich, 301 knots. Flight level 22,200, make a right turn. This is gonna be followed by the autopilot. 12 nautical miles, Mativ, 320 knots, 11,200, 6 nautical miles, Zurich. Amiki, 9 nautical miles, Zurich. Zurich 701, 186,000 Alpha. TRA, 10 nautical miles, CI 14, 6 nautical miles, Osnem. We make left turn to align with the runway for approach and landing. 170 knots, 4,000 Alpha, runway 148 nautical miles from Osnem, 140, 1,450. So we set flaps for takeoff, 15 degrees, center of gravity 33%, 4.25, takeoff space V1, we rotate for this gross weight in the runway. So we have departure arrivals, alternate VNAV, progress, FMC communication. We can hold over a waypoint, set a fixed radial, and the navigation radio over here, set a tune Lszh, localizer, roar. So we go back in the virtual cockpit. We need to set the flight management computer now. We just did that. We can see a little bit more of the displays again. So I talked to you about primary flight display. Now you can see the flight plan here created. Also the terrain you can see. We look closer. The flight plan is going to be shown with a purple line we need to follow from takeoff, climb, cruise, descent, approach, and landing. The runway also position. The vertical you can see the terrain and the cruise level we cannot change. Also the terrain below us and the line of climb over here. So we look even closer, we will see the runways and the taxiways. In front of us we have a taxiway for taxiing into the airport. The runway, also the terrain. This is 5 nautical miles range. So you can see this is the taxiway. This is the runway we're gonna use for takeoff and for landing. So it's the same one as displayed in the GPS. Also the terrain around us and in front of us. If we have low visibility or it's night, we can see the terrain over here in the navigation display and follow the flight plan. So you can see the terrain with yellow and green. Also if we look at the center display, we have a 360 degrees view over here. Also the flight plan, then center, and we have one more view here, the flight plan. As you can see, map setting. It's for navigation purposes only. So we use this view. We're going for the engine start demonstration. We need to set up, you can see the APU to the start position. We need to start the APU to restart the engines. IGT 100 to 200 volts for 100 Hz frequency. The battery 180,000 kilovolts. Primary flight control computers in the auto position. So the APU is gonna give us electric power and pressurizer. The air data computer, primary flight control surfaces, also the battery over here, the towing power, FD door over here, passenger oxygen over here, window heat over here, rammer turbine, left and right engine. We have the backup hydraulic rammer turbine. If we turn off left and right primary and demand. You see the fault displayed. We have the electric and the rammer turbine as a backup. So we turn back on into the auto position with the engine at the ice over here on an auto position. Also we have the cabin pressurization. You can see the outflow valves in the auto. In the manual we use the outflow valves open and close when climbing descent to pressurize the aircraft. In the auto we need nothing to do. It's automatic. We have air conditioning for hydraulic fluid tanks, oxygen and cabin pressurization with the engine at the ice. Also you can see here the recorders, also carbon APU fire, electronic engine control for the engine here with the auto start, normal and alternate modes that control the farex, fuel jettison, get dumps of fuel in flight, rearm the switch and the nozzles and how much to remain. Fuel booster pumps here inside the tank. The crossfit valve is off, we turn it on, you can feed either engine without the pump or either tank and balance the fuel between the left and the right wing. So we turn off these valves. So this is all we need to know for the overhead panel systems. Very quickly we need to go over here also, so you the displays one more time, a bit faster. So we have the displays here, the systems over here, all the systems you see in the overhead and some others, hydraulic, APUs running, oxygen, quantity liquid cooling, the electric here. Now it's the electric page. You can see we have the left and right IC 120,000 kilowatts. Also the APU is running. The main battery and the APU battery charge and discharge. You can see the drives are connected. Also the load cell. Also we have hydraulic fluid tanks over here. Quantity and the pressure with hydraulic fluid 5100 psi. Also you can see where the hydraulic fluid goes, which systems use hydraulic fluids, set of valves, isolation valves, set of valves, primary demand, left and right engine driving, electric C1 and C2. Fuel you can see left and right wing and the center tank 11,000, 11,000, 11,000 total 33,500. You can see the minimum fuel temperature down here below, which the fuel which is in flight minus 37 degrees, and the fuel temperature right now is minus 6. So the FAREX, the full authority, is electronic control computers that control the engine's functions. You see here also transfer the fuel when we fly at low temperatures automatically to heat up the fuel into the engine components. Also the lubricant and the oil from the wing tanks and the center tank. The low and high pressure fuel valves open and feed both engines. The crossfit valve with an can feed either engine without a pump or either tank. The APU is fed from left wing using the DC motors. The crossfit can balance the fuel between the left and the right wing. Air pressurizer for cabin pressurization, wing and engine at the ice, oxygen. Also the doors are closed, the cabin can be pressurized, the gear, you can see the temperature of the brakes and the pressure of the tires, flight controls. Over here you move the flight controls. This is one of the last things we need to check before going to flight. All flight controls are active. You can see the wings, left and right wing over here, movement and the tail, climb, descent and the rudder. The limits also FS display over here. This is for maintenance also purposes, and circuit breakers maintenance. So we have also the checklist, normal menu, before start, after takeoff, descent, approach, lighting. Also communications, we have the navigation display again, so we need to restart the engines very quickly. So we go down here, fuel transfer valves both in the off position, left and right engines. You will see now the messages coming up and you see the engines are going off. So we look outside, you can see the engines are out. So we're gonna restart them. Over here in the overhead panel you can see left and right engine auto start in the start position. Also illuminates the switches with an amber color. So we have the low pressure compressor turbine and the low speed south. Only the high pressure compressor turbine here has pressurizer admitted for the engines started right now from the APU. So we can let the fuel control, fuel valves both on, left and right engine on. So we have the auto start here coming up. You can see the N2, which is high speed starters have high pressure compressor, one 200 with the engine, and one with the low speed starters have low pressure compressor, one 200 with the engine, fuel flow, exhaust gas temperature, oil pressure, oil temperature, oil quantity, and the vibration of the engine, one stage of the engine. So at 50%, you can see the messages going off. So at 61%, we're gonna be having running both engines, these messages. So we can set flaps for takeoff, speed brakes armed, and we set the autopilot for takeoff over here, the autopilot panel. Last thing we need to do. So we have the auto throttle left and right, disarm, LNAV and VNAV, flight director, on and off, disarms the modes, autopilot, disengage, flight level change, climb continuous. So we're gonna set the airspeed like this. Also the bank angle in flight, limit and heading. We're gonna set the heading of the runway. I'm gonna use for takeoff and for landing. Set 136 degrees vertical speed. We have zeros, we have descent, you can see the minus sign, and we have climb like this. You'll see the plus sign. Also the altitude here, thousands, and then hundreds of feet. So we have the autopilot set for takeoff, and after takeoff, brakes off, advance the thrust levers. We take the clearance from the air traffic control, give us the taxi to the runway. The runway is open for us, we can use it for takeoff. So use the tiller again. You can see the runway also is open. There's no other aircraft. Also we can see from the radar the traffic. There is no traffic in the runway. So we align with the runway center line over here. So we advance the thrust levers when we align the center line. As you can see, we'll take off also here. And we push the yoke down until 80 knots, or the side stick in the Airbus. Same thing, along with the rudder pedals. So we have 80 knots, 110, 120, 130, V1, we rotate over here, as you can see. So we pitch up 9 degrees for rotation, for takeoff, to avoid the tail strike. Don't pitch too much, more than 9 or 10 degrees. So we keep climbing. As you can see, we have positive rate of climb, landing gear up, as you can see, and we have 18 more minutes for the flight to complete. So you can see here the terrain. You can see also the terrain with red, green, yellow over here. So we are 2000, you can see 2200, 300, 400 feet above the ground, but 4000 feet above the sea. The airspeed right now is 191 knots. We have the wind direction and speed 9 knots over here. We climb with 4000 feet. The altitude of the aircraft, also the terrain, red, green, yellow, the flight plan, this purple line we need to follow. So increase the range. You can see also the engine indications. You see red, green, yellow, the mountains in front of us. We have low visibility. Also the stall speed displayed with red and yellow. We need to avoid stalling the aircraft. So we fly closer like this. You can see now we have the terrain below us. This is the aircraft. It's 8000 feet approximately and 5,500 feet above the ground. You can see this green line up to 20 nautical miles. In front of us is the ground below us as we're climbing. So this is the air data, also the stall speed. So we need the outside view over here. We need to make a turn now. As you can see the runway. As we depart, we need to turn. So we start to turn now. Also use rudder pedals. So we look a little bit to the right over here as we climb. So the outside view. So you see also the head-up display. What it reads, flight director. The navigation display over here. Again, the flight instruments and the engines. So we're gonna be flying through this way. Hope you like the view. As we climb, also inside the cockpit, just after takeoff, all switches are normal, as you can see. So we have one of the most beautiful views here. We keep climbing the Boeing 787. We like the view from the Switzerland over here, the Swiss Alps, and the lakes, also the Germany in front of us, my homeland, and the France. So we need to make some turns here. You can see we can fly level without the autopilot, leaving the side stick, no problem. Keeps turning, only the aircraft can do that, as you can see. Now we can get the control, make some corrections. Use right rudder also for this turn to make it a little bit faster. So we need to cross through the Zui here. You can see it says it's 1.7, 1.6 nautical miles. The Zui is here in the map. Then we have Negria. You can see the airspeed, the stall speed is 120 knots. Keep climbing. So we're gonna make some turn now. Follow the flight director over here. We need to follow the flight plan. Also we can connect the autopilot for a couple of minutes. For display you're gonna see the autopilot flying the aircraft also. So you can see here again where we are. We have this France view, the Germany, my homeland in front of you, the lakes, also the Switzerland here. So we keep climbing. You can see we are 20,000 feet. We can connect the auto throttle left and right. The autopilot will fail the first one, so re-engage, and we decrease the rate of climb like this. 100 feet per minute. So we climbing now, also flaps up, and now the airspeed we can increase the airspeed like this. So now we have the autopilot engaged over here. As you can see, command the aircraft following. You can see autopilot engaged, the airspeed and the altitude also here. So we need to make a turn now. You can see we're gonna use the waypoints here following. Next waypoint, press the execute, will give us a turn over here, turn around. You can disguise the autopilot, follow like this. We're flying now manually the turn over here, and then we can reconnect the autopilot, there is no problem. Run manually the turn like this, 20,000 feet plus. Manual turn, as you can see, no problem, 8,000 feet. So you see where we are right now. The aircraft is 22,000 feet. We have the handrails. We are overflying the lake, the Germany, Bayern Munich, very close, and the Düsseldorf and the France on this side, and we have the vapors, frozen vapors. So we need to align over the lake with the flight plan over here, increase the rate of turn. So we align manually right now. As you can see, we have manual flight controls, and then we re-engage the autopilot if we need. We engage the autopilot. So we can fly now straight over here. To the Zui. Then we have a discontinuity. We need to use approach over here. Press the execute, and we have the flight plan again created. So we need to follow over here. As you can see, fix the flight plan. We are almost having this beautiful view. We're gonna start the descent. We're flying with the autopilot now, as you can see. So we need to start the descent now of the aircraft. So we make a turn. You have the most beautiful view of the galaxy here, as you can see. The lakes behind us, the Germany over here, and the France. So we start the descent now. Descent rate increase also. Speed brakes extended. Now we fly manually again, and we have 6 more minutes for approach and landing. can engage the autopilot to the descent if we need decrease the altitude here. And the vertical speed minus. So we keep descending like this, idle thrust. We have 5 more minutes for approach and landing. We can rearm the autopilot if we need, like this. It will give us again alignment. You can see autopilot engaged for descent and the rates we have set for approach and landing. So we can disengage again, use manual thrust and manual also flight controls. So we start the turn now for approach and landing over here, as you can see. Keep descending, manual flight controls also align. You can see the displays, the arc of descent over here. We need to start the turn now as we are descending. So this is the turn over here for approach and landing. Use a little bit left rudder to align with the flight line as we are descending. So we need to align with the flight line here. Also with the airport, the runway. So we have a few more minutes for approach and landing over here, as you can see. We're following this line here, the approach line. Just a little bit more thrust. Need to advance the thrust levers. So landing gear down. See idle thrust also. So landing gear down. We'll have the view for landing the aircraft. More thrust needed. More airspeed. We have 1 more minute left. Also the flaps, start using the flaps down. A bit more idle thrust, as you can see. Align with the runway. We have some side wind over here, some wind gust. So we need to use cross controls, rudder pedals, ailerons and spoilers. So we have also the ILS localizer here, as you can see in the screen of information we need for approach and landing. So useful. A little bit more thrust, more airspeed. So align with the center line. Stay center line over here. With the right rudder, increase also the rate of descent. idle thrust, making more idle, increase the rate of descent, align with the center line over here. So we're going to be having the flare in a couple of seconds, flare over the runway here, as you can see. So this is the flare, very beautiful flare, very beautiful touchdown, idle thrust, very beautiful, very professional. So parking brakes and align with the rudder pedals with the center line, and use thrust reverse, full thrust reverse over here, align again with the center line. So this is slowing down the aircraft. You can see all landing gear, it's perfectly safe. Also the thrust reverse over here. So we're slowing down. You can use idle thrust reverse like this. Thrust reverse is disarm.